Number 1. Write an equation in point-slope form of the line that passes through the given point and with the given slope m. So let's take a look at it. Now y minus y1 equals m times x minus x1 is point-slope form. It is named as such because we have our slope and x1 and y1 is one of our points. So basically what we do is we take our point and we change the signs of them. So 2 becomes y minus 2, negative 3 becomes x plus 3, and then 2 goes in for the slope because that's our slope. So we have y minus 2 equals 2 in parentheses x plus 3. So let's type it in. So y minus 2 equals 2 parentheses x plus 3. And that's number 1. Number 2, graph the equation. Click to enlarge the graph. It's in point-slope form. Our slope is negative 4, and we have a point. So change our signs. X is positive 1, y is positive 4. So we start at positive 1, positive 4, and then we have a slope of negative 4. So we go down 1, 2, 3, 4, to the right 1. Press save, check answer, and that's number 2. Number 4, write an equation in point-slope form for the given line. Making this graph larger, we see it's a decreasing line, so that means it can't be B or C because they're increasing lines because they have a positive slope of 2 over 7. So now we look at our points. Here we have positive 5, positive 4. So that means in the equation, we should have x being 5 and y being 4. So it should be y minus 4 and x minus 5. 5 going with the x and 4 going with the y. That means A is going to be our answer. 5. Write an equation in point-slope form of the line that passes through the given points, then write that equation in slope-intercept form. So let's do that. So the first thing we got to do is find the slope and identify x1 and y1 and x2 and y2. Substituting our numbers, we get 1 minus 7 is negative 6, 9 minus negative 9 is positive 18. So negative 6 of 18 reduces down to negative 1/3. So the slope is negative 1/3. So now we're going to put our slope and either negative 9/7 or 9/1 in for x1 and y1. I'm going to choose the second pair only because there's no negatives in there. So then I'll have y minus 1 equals negative 1/3 times x minus 9. Change the signs. 1 is y, 9 is x. So let's type that in for the point-slope form before we go to the slope-intercept form. So we have y minus 1 equals our slope of negative 1/3 in parentheses x minus 9. Now in slope-intercept form, let's go back and put it in that. Putting it in slope-intercept form means I have to solve for y. So I distribute the negative 1/3 into everything, and I'll get negative 1/3 x. Negative 1/3 times negative 9 is positive 3. So from there, I add 1 to both sides, and I'll get y equals negative 1/3 x plus 4. So that's the equation in slope-intercept form. So let's type that in. So y equals negative 1/3 x plus 4. And that's number 5. 6. Model the data in the table with the linear equation in slope-intercept form, and then tell what the slope and y-intercept represent. So let's take a look at it. So to find the slope, you need to find the change of y over change of x. Change of x is 2. Change of y is 13. So we have 13 over 2, which equals 6.5. We do want a decimal in this case. So now we're going to put that into point slope form. Slope is 6.5, and I'm going to use the first point. X is 1, so x minus 1, and y is 6.50, so 6.5 will go here. Now, we need to find the y-intercept. So distribute to 6.5 on the right, and then add 6.5 to both sides from here, and we get y equals 6.5x. Now that it's in slope-intercept form, we can see what the y-intercept is, which is 0. There's nothing there. So let's type that in. So I'm going to type in 6.5x. Now it says, what does the slope represent? That is the amount of pay we're getting every hour. So the rate of pay in dollars per hour. The y-intercept represents the initial wages earned in dollars. This is where the time is 0, so that'll be the initial wages earned. That's number 6. Number 7. Graph the line that passes through the given point that has the given slope m. Here we're given the slope and a point. So start at that point of 2, 6. Now for my slope, it's a negative 1/5. So go down 1 to the right, 1, 2, 3, 4, and 5. Click it, press save, and that's number 7. Number 8. The relationship between altitude and the boiling point of a liquid is linear. At an altitude of 8,300 feet, the liquid boils at 198.89 degrees Fahrenheit. At an altitude of 4,700 feet, the liquid boils at 205.01 degrees Fahrenheit. Write an equation given the boiling point B of the liquid in degrees Fahrenheit in terms of altitude A in feet. What is the boiling point of the liquid at 2,100 feet? First, let's establish that x is the altitude and y is the boiling point. Because the altitude is what makes the boiling point what it is. The boiling point depends on the altitude. So, writing in the table, we find change of y over change of x. Change of x is negative 3,600. Change of y is positive 6.12. So we have 6.12 over negative 3,600. That gives us negative 0.0017. Leave it as a decimal. That's our slope, and now we got to find an equation for it, so let's use the point slope formula. So looking at our table again, I'm going to choose the first pair of points. You could have chosen the second pair and gotten the same answer. Putting it in, I have the 198.89 for y, the 8,300 in for x. Now I solve for y. So first I distribute the negative 0.0017, and then I will add 198.89 to both sides, and I'll get y equals negative 0.0017x plus 213. Now it wants us to write it in terms of b and a. B is going to be y, a is going to be x. So that's our equation. So let's type that in first. Typing it in, we have negative 0.0017 a plus 213. Good, so now let's go ahead and find the boiling point at 2,100 feet. So substitute 2,100 in for A. I multiply and I get negative 3.57. I add that to 213 and I get 209.43 degrees. So let's type that in. So typing in 209.43. And that's number 8. Number 9, it says using the graphing calculator, graph f of x equals 3x minus 5. That has a y-intercept of negative 5, so looking at my first choices, that's going to have to be C, because all the others have a y-intercept that's positive. J of x is if we're adding 4 to the function. Adding 4 to negative 5 gives me negative 1. So that's going to be 3x minus 1. Now the graph of that will be the one with the negative y-intercept, whereas these two have a positive y-intercept, so it has to be C. So how does the graph compare from f of x? Both graphs have the same slope, but different y-intercepts. Only the y-intercepts changed. Now, k of x, we are adding 4 inside of the function, replacing x with x plus 4. I distribute to 3, I have 3x plus 12, and then 12 minus 5 is 7. So my new equation is 3x plus 7. So let's type it in. So type in 3x plus 7. Now my graph. It's a positive slope, so we know it can't be A. It's a positive y-intercept, so it can't be B. That's a negative y-intercept, so it has to be C. Now how did the graphs compare? Well, the slopes didn't change, but the y-intercepts did. So they had the same slope, but different y-intercepts. So compare how adding a number to a function and adding a number to the x value changed the graphs of the function. Well, as we saw, adding a number to a function and adding it to the x value both change the y-intercept, but keep the slopes the same. And that's number 9.